Hello and welcome to Basic Electricity 2 Troubleshooting Shorts. The purpose of this lesson is to teach you the basic theory behind troubleshooting a short in an electrical circuit. At the end of this lesson, you should be able to define a short, explain the process of finding a short, and then find a short in a circuit. A short is an unintentional bypass of a load. Note that this is different from a shunt in that it is bypassing a load and not a control device. The red line that you see in this circuit is an example of a short. Recall from Basic Electricity 1 that the most current will flow through the path of least resistance. We proved in that class that the total resistance of a parallel circuit will be less than the lowest resistance of that circuit's parallel loops. So if this circuit has a 5 ohm resistor, a 20 ohm resistor, and a 30 ohm resistor, the total resistance will be less than 5 ohms. Now, with a short circuit bypassing a load, it's effectively placing another loop in parallel with that load. That loop will have an extremely low resistance, often very close to 0 ohms. When this happens, the total resistance of the circuit, that is, the resistance that the source sees, is also extremely low. This will have consequences on the circuit, which we will discuss in a moment. But first, let's take a look at this circuit, which contains 3 switches and a lamp for a load. The device on the left is an ohm meter measuring resistance to ground. Let's put a short between the first and second switch. When we measure resistance with an ohm meter, we get a path of low resistance through the short. If we open the first switch, our path through the short is broken. When we reclose the first switch, our path for current returns. Now, when we open the second and third switches, we see that we are unable to break the connection between the meter and the short. It is this principle that will allow us to isolate a short in a circuit. Before we dive into the circuit though, let's take a look at a few rules for finding shorts. First, shorts blow fuses. Fuses blow because of a high current condition. In a shorted circuit, the short introduces an extremely low resistance to that circuit. Based on Ohm's law, if the resistance of the circuit goes down, the current through that circuit is going to rise. When a circuit is shorted, this rise will usually be high enough to blow the fuse. Second, when troubleshooting a short, you should use an ohm meter or the ohm meter function on your multimeter. Note that this will require the circuit to be de-energized because we never take an energized resistance reading. Third, you will break the circuit using the control devices and terminal ends to isolate the short. If you open a switch and your ohm meter goes from low to high, then your short is downstream of that switch. When you reclose that switch, the meter should return to 0 ohms. On the other hand, if you open a switch and the ohm meter indication remains at 0 ohms, the short must be upstream of that switch. Once you have exhausted all of your switches, you can begin lifting leads to see if the short is in a wire or in a component. If you lift the lead and the meter goes from low to high, then the short must be downstream of the break. When you reconnect the lead, the meter should return to a low resistance. If you lift the lead and the meter continues to show a low value, then the short must be upstream of the break. At this point, there's only one place left to check. As you isolate, you will find that the short is at the last isolated component that shows continuity to ground. Now let's try some practice problems. Consider this simple circuit, which contains a 120 volts DC battery, a single fuse which is blown, 3 single-pole single-throw switches, and a lamp. With all of the switches shut in this circuit, the lamp does not energize. We check our fuse and we find that it is blown, so we know we're looking for a short. We connect our ohm meter downstream of the fuse, connecting the common lead to ground, and measure low resistance. We open our first switch and the resistance reading goes from low to high. Does this mean that the short is downstream or upstream of this switch? I will pause the video at this point to give you time to consider the answer. When you think you know it, push the play button to continue. If you said that the short is downstream of this switch, then you are correct. The switch broke the connection between the meter and the short. When we reclose the switch, the meter indication returns to 0. Now, I open the second switch and the meter goes to high resistance. Is the short downstream or upstream of this switch? If you said it was downstream, then you are correct. Once again, the switch was able to break the connection between the meter and the short. When we reclose the switch, the meter indication returns to 0. Now, when I open the third switch, the meter indication remains at 0 ohms. Is the short downstream or upstream of this switch? If you said upstream, then you are correct. The switch could not break the connection between the meter and the short, so it must be upstream of the third switch. Ultimately, the short is somewhere between the second and third switch. To recap, we've defined a short, identified key troubleshooting points, and gone through a few practice problems. I hope you have enjoyed this lesson. If you have any questions, please leave them in the comment section below. Have a great day.